normal healthy wrists. With training, you can go beyond that.
I'm pretty sure we all know Lat Movement by David at this point. Great page, really cool guy, was nice enough to allow me to use his video to work out some of the applied anatomy and weight-bearing points in this interesting movement. To explain some of the drawing process here, I'm just blocking out the major body regions. This gives us a general location and motion capacity for each area. And then we have the skeleton, which is not totally essential to explaining the movement, but I really like skeletons. Let's start by talking about this obscene wrist angle. It is somehow beautiful and uncomfortable looking at the same time. But we have a trained professional here who spent a lot of time building up the capacity to do this, so for him it is safe. The hands are the main support point, or you could also call that the main fixed point, because they are touching the ground. But you'll see each point must support the next for any of this to work. The hands are connected to the forearms, and you have to understand that they are wobbling back and forth essentially the entire time. You could argue that it's mostly the anterior compartment of the forearm, the front part, doing the job of pulling the body forward because the body is pulling posterior by weight. I don't disagree with that, but it's got to be both front and back of the forearm. Interestingly, this movement utilizes the ability of the elbows and shoulders to lock out by pressure. The shape of each joint allows them to bear weight directly through their bony surfaces, meaning they don't require nearly as much muscular support. This is not unique specifically to this move, but it's also something the legs do quite naturally when standing. There is, of course, some support by the muscles for you triceps fans out there. As we get into how the entire trunk and lower body is moved up relative to the arms, it does get a little bit confusing. The way I like to make sense out of this, to make it more simplistic movement, is to reverse the fixed points. Instead, we'll flip this image upside down and say the trunk is stationary and the arms are moving up, carrying the weight relative to the trunk. So this will be just like lifting the arms straight out in front of you while holding onto some pretty big dumbbells on each side. The whole area from biceps through delts is shortening, so those are likely the most contracting muscles. Realistically, it would be mainly the anterior and lateral, the front and side parts of the delts though, which is really impressive that they're even capable of that. However, we'd be needing a lot of scapular stabilization also, so easily the rhomboid and traps are being used for that. Now I'm going to make a ridiculous statement here and say that the lats are involved to stabilize the spine and pelvis. The lats technically wouldn't be shortening in this movement, they would actually be lengthening, which normally means it's inhibited or they are relaxed. But this doesn't mean they are not going to be maintaining a base level of contraction or preventing certain amounts of lengthening at the same time as you transition through this phase of the motion. The lats also add internal movement of the arms and therefore hands, bringing them inward, which adds to grip. And we could add the pectoral muscles to this equation as well. Lastly, because the lats are running vertically, that also adds to the dynamic compressive stabilization of the body. For the erectors, this is the reverse action that they normally do, but to keep that back maintained and that pelvis from just dropping out, we need to have erector spinae muscles contracting most of the way throughout the back. Because the erectors are sequential layers of vertical tissue, essentially every bone holds every other bone via those interlacing muscles. And though it isn't obvious, to assist the spinal stabilization, we need abdominal contraction, the ab muscles. The abs will help us to stabilize the entire pelvis because they really go from QL all the way through the center to the opposite QL. Internally, it's essentially creating organ pressure that further supports the pelvis. Once the pelvis is supported, we can bring in the legs. Very quickly, it's the glutes and hamstrings to create hip extension. Now, the gastrocs are there and they would be supporting the knees too. So you can definitely see that a movement like this requires the whole body throughout. And as long as you have superhuman strength and ultra-fine muscle control, it should be just as easy for you to do too.